Hello students, in this session we are going to discuss about the continuation of the rank of the matrix, that is consistency of the equations of system of equations. Consistency. Say what is consistency and why it is important, where it is used. Okay, we are going to discuss one by one. Suppose if we have a system of equations in this form, let me take some system of equations a11 x1, a12 x2, a13 x3 dot a1n xn equal to some b1. Similarly, a21 x1, a22 x2, a23 x3 dot a2n xn equals to b2, a31 x1, a32 x2, a33 x3 dot a3n xn equal to b3. So if we continue this in this form, so it becomes an1 x1, an2 x2. Later I am taking ann, so that's why I will take am1, am2, am3 x3 dot amn xn equal to some b. These are just notations, you can use whatever it may be. Now these are some system of equations. Okay, these system of equations, if we represent in the matrix form, how it looks, you just see here, it can be written in the form of ax equal to b. Ax equal to b. Here this A is called what? Coefficient matrix. Coefficient matrix. And this B is called right hand side, that is RHS, non-zero column matrix. Non-zero column matrix. Non-zero column matrix. And this X is called variable matrix. Variable matrix. Okay. So this given system of equations, we can also be written in this form Ax equal to b. Here A is called coefficient matrix, X is called variables which are involved in this, like x1, x2, x3. They are all variables. They involved, that's why that matrix is called variable matrix, and right hand side matrix, that b1, b2, b3 represent the b. So if I express in this form, how it looks? So A equal to, it becomes what? a11, a12, a13 dot a1n, a21, a22, a23 dot a2n, a31, a32 dot a3n. Like that it will continue. And then x, this x indicates variable matrix. So x1, x2, x3 dot xn. And the right hand side matrix, that is b1, b2, b3 dot. Now this given system of equations we have expressed in the form of matrix, and this is nothing but this form Ax equal to b. Now what this consistency says, if the given system of equations are said to be consistent only if they possess solution, means only if it has solution. Solution we all know, if the right hand side equal to RHS, left hand side is equal to right hand side, then the equation is balanced, means it has a solution. Okay. So if any system of equations possess any solution, then we can say that that system of equations are said to be what? Consistent equations. Okay. Otherwise, that system of equations are inconsistent equations. Okay. So now, if they are consistent equations, means they have to possess some solution. Now, what type of solution they are having? Let me check. That we are going to discuss in this session. Okay. So everyone should remember, consistency means, suppose they have given some system of equations, maybe problem contains some system of equations. If we say that the given system of equations are said to be consistent only if they possess solutions. Okay, otherwise they are inconsistent. Now Here we have Ax equal to B matrix. From this I'll write one important thing, that is I'll just remove this part. So I'll write A is to B, A is to B. So how it looks, A is to B. So A will be like this, A11, A12, A13, A1n equals to the corresponding element of B is B1. Next, A21, A22, A23, A2n corresponding element of B is B2. Like that, if we write this A and B in this form, and this will be referred as what? Augmented matrix. Okay? Augmented matrix or augmented form of the matrix. So this is very important for finding the different kind of solutions or to discuss the different type of solutions. Now, how to find the solution of the given system of equations based on the consistency concept. There are three types of solutions we have. What are those three types of solution? Unique solution, infinitely many solution, and no solution. Before that, we have to do one small operation, one small process. What is that? We see what is the steps to solve the problem. Steps. Step 1. Write the given system of equations in the form of augmented matrix. That is formation of augmented matrix. Augmented matrix. We have to form the augmented matrix from the given system of equations. Once that is over, step 2 says using row operations. Using row operations, convert the augmented matrix, the A is to B augmented matrix into echelon form or row echelon form. Okay, echelon form or row echelon form. We have to convert the augmented matrix into echelon form by using row operations. Once it is converted into echelon form, then we have to discuss the possible solutions. Echelon form means we all know that the lower triangular elements are supposed to be 0, because if I consider one 3 cross 3 matrix, let it take A11, A12, A13, 0, 0, B12, B22, 0, 0, and it may be anything, 0 or whatever it may be, let me write B23, 0 or C3, whatever it may be. If the lower triangular elements are 0 using row operations, then that will be referred as what? Echelon form. If the diagonal elements are 1, then will be referred as row echelon form. That you remember. Now, if we convert the given augmented matrix into echelon form, then there are three possible solutions we may discuss. One is what? Unique solution. This is very important. Kindly note the points. Unique solution. When we say that the given system of equations are having unique solution, first thing we have to find out rank of the augmented matrix, means rank of the whole augmented matrix, that should be equal to rank of the coefficient matrix, means only this part. After converting the echelon form, you have to consider only this coefficient matrix, this rank. And this should be equal to number of unknowns. N indicates what? Unknowns. Means that variables x1, x2, x3. If the augmented matrix rank and the coefficient matrix rank and the number of unknowns all are same, then we can say that the given system of equations has a unique solution. Unique solution. This is very important. Then the second point is infinitely many solution or infinite solution. When it is possible infinite solution, when the augmented matrix rank and the coefficient matrix rank both are set. Remember here, augmented matrix rank and the coefficient matrix both are same, but it should be less than what? Number of unknowns. It should be less than the number of unknowns. Maybe the rank will be 2, but the number of unknowns will be 3. That time we may tell the system of equations having infinitely many solutions. When this possibility is there, then you can choose n minus r unknowns. N minus r unknowns arbitrarily. Arbitrarily means out of 3 variables, if the rank is 2, 3 minus 2 is 1, so 1 unknown we can choose it arbitrarily. That is infinitely many solution concept. The third one is, if the rank of AB itself not equal to rank of A, means the rank of the augmented matrix itself is not equal to rank of the coefficient matrix, then we can say that the given system of equations are inconsistent, means that does not possess any kind of solutions. Okay, inconsistent. So I hope it is clear. So there are 3 types of solutions we are going to find for the given system of equations. One is unique solution, infinitely many solution, no solution. Unique solution means rank of AB, rank of A, number of unknowns must be same. Infinite solution means rank of AB, rank A must be same, but it is less than the number of unknowns. And the inconsistent means the rank of AB itself is not equal to rank of A. Okay, so these are the possible solutions may have the given system of equations. We'll solve some problems. So I am going to solve 3 problems on each solution. Okay, so that you will get to know easily. So we'll do problems one by one, and it is very important concept. So it is based on the rank. So those who are new to the system, kindly refer my previous videos based on the echelon form and rank, so you can easily get it. I will take one problem. What is that? Test consistency for the given system of equations. What are those? X plus y plus z equal to 6. X minus y plus 2z equal to 5, 3x plus y plus z equal to 8. Okay, this is the given problem, in a given system of equations. We are finding the solution. Our first job is what? First step, we have to write the augmented matrix. That is A is to B. Augmented matrix equal to. So write the coefficients of first equation. What are the coefficients? X coefficient will be 1, y coefficient will be 1, z coefficient will be 1, and the corresponding value will be 6. Second equation, x coefficient will be 1, y coefficient will be minus 1, z coefficient will be 2, and the corresponding right hand side value is 5. Third, x coefficient will be 3, y coefficient will be 1, z coefficient will be 1, and the corresponding element will be 8. So if you convert the given system of equations into this form, usually 1 mark will be awarded in the exam. To write the augmented matrix from the given system of equations, you can easily write 1 mark without solving the problem from the given system of equations, 1 mark. Now we have to convert this into echelon form. Okay. Now what we are supposed to do? We have to make below this elements are supposed to be 0 by using row operations. That is R2. R2 implies this element is supposed to be 1. Therefore R2 implies R2 minus R1, and R3. This is supposed to be 1, 0. So this is 3. This also become 3. 3 minus 3, it is 0. That is the reason. It is R3 minus 3 times R1. If we do that, then we have the remaining matrix. See, all the row operations are independent operations from the given matrix. Okay, this R2 is applicable only for this term. R2 is applicable only for this term. Don't change R1. R1 will be as it is. 1, 1, 1, 6. 1 minus 1, 0, minus 1, minus 1, minus 2, 2, minus 1, minus 3, 5, minus 6, minus 1. We are subtracting the elements of R2 with R1. That will be the new elements of R2. R3, what we have done? We have multiplied R1 with 3. Okay, I just write here 3 ones are 3, 3 ones are 3, 3 ones are 3, 3 6 are 18. By pencil small works you write. So 3 minus 3, it is 0. 1 minus 3, it is minus 2. 1 minus 3, it is minus 2. 8 minus 18, it is minus 10. Okay, we are subtracting the elements of third row with the first row, and the first row elements are multiplied with 3. Now these two elements are 0, we have to make below this element as 0. That is next step. So this is minus 2, because to make lower triangular element 0, it has to be 0. Minus 2 becomes 0 means if I subtract both, minus 2 minus of minus become plus. Minus 2 plus 2 0. So R3 implies R3 minus R2. So then A is to B becomes what now? First row we have not done anything. 1, 1, 6 as it is. Second row we have not done anything. Minus 3, minus 1 as it is. This you see. Please remember one thing. Once these elements are 0, don't use first row for any other operations. Why? Because if you use first row, again these zeros become some other numbers. Okay, for adding, subtracting. That is the reason. Once these elements are 0, don't use this row for other further simplifications. Okay. 0 minus 0, 0, minus 2, minus 2, minus of minus 2 plus 2, what is 0, minus 2, minus 2, minus of minus 3 become plus 3, minus 2 plus 3 is what? 1, minus 10 plus 1, so it becomes what? 9. This one I hope it is clear. 1, 1, 1, 6 as it is. This one R3 minus 3 R1. These two operations, say 1 minus 1 0, minus 1 plus 1, I mean minus of minus, it becomes what? Minus 2. I have written 2 minus 1. Here I think done a mistake. Just re-look into the operations, because so one operation I think I'll check it once again. Now I will check it. 1 minus 1, it is 0. Minus 1, minus of minus 1, because R2 minus R1. 1 minus 1 0, minus 1 minus 1, minus 2. It becomes what? 2 minus 1. R2. 2 minus 1, it becomes what? 1. 5 minus 6, it becomes what? Minus 1. I think I have added, that's why I got 3. That is the reason something wrong is here. Then 3 minus 3, it is 0. 1 minus 3, it becomes minus 2. 1 minus 3, again it becomes minus 2. 8 minus 18, it becomes minus 10. 8 minus 18, it becomes minus 10. So now this I write as it is. It is 1. First row, second row, change only third row. 0 minus 0, 0. Minus 2 minus of minus 2 plus 2, 0. Minus 2 minus 1, it is minus 3. Minus 10 plus 1, it is minus 9. Because it is minus. See here, one sign also matter a lot. If I miss one, see I just missed here plus, that is the reason the answer I got wrong. And now you see the lower triangular elements are 0. Once the lower triangular elements are 0, it is in the echelon form. Now we can easily find the rank of the matrices. So whenever this comes to the consistency part, no need to make these diagonal elements one, straight away you can find the rank, no problem. Okay. Therefore, rank of AB, that is rank of the coefficient matrix, whole matrix, augmented matrix. You see here, this is non-zero row, this is non-zero row, this is non-zero row. 3 non-zero rows are there. So rank of AB will be 3. And rank of A, you see only this part. This is coefficient matrix. Okay. This is non-zero row, non-zero row, non-zero, because this 3 is non-zero element. That's why the rank of A is also 3. Therefore, rank of AB is equals to rank of A is equals to 3, and it is equal to number of unknowns. Number of unknowns x, y, z. 3 unknowns are there. N will be 3. So therefore, rank is same. Number of unknowns are same. We can conclude that the system of equations or the given system has unique solution. It has unique solution. So when it has unique solution, we have to find out that x, y, z values. Okay. So in this augmented matrix, echelon form matrix, we have to multiply x, y, z with all the rows. X, y, z with all the rows. The last row we will start. It is 0 into x, 0 into y, 0y, minus 3 into z equal to minus 9. So from this we will have z equal to 9 by 3, that is 3. Z value as 3. Then I move on to the second equation. Second equation will be, so this is my first equation. This is second equation, 0 into x minus 2 into y plus 1 into z equal to minus 1. Minus 2y, z value is 3, that is equal to minus 1, minus 2y equal to plus 3 goes to that side means minus 3, minus 3 minus 1, minus 4, or y equal to what? 2. And I will take the first equation, so that is 1 into x, x, 1 into y, y, 1 into z, z, that is equal to 6. We know x value, we don't know x value, we know y value, z value. If we replace here, x plus y value is 2 and z value is 3, that is equal to 6. This is 5. X plus 5 equal to 6, or x equal to 6 minus 5, 1. Therefore, the solution of the given system of equations are x equal to 1, y equal to 2, z equal to. So this is how we are finding the solution. So steps, remember, augmented matrix first, converting augmented matrix into echelon form by operating row operation, then finding rank of augmented matrix coefficient matrix. Here number of unknowns and rank is same, therefore system has unique solution. Once the system has unique solution, we have to find out the solution. The solution will be obtained by multiplying x, y, z for all the 3 rows. We will go from the last row because it is iterative from back substitution, because the third row contains more number of zeros. So if we start from here, we will get answer solution easily, starting solution. That is the reason. Okay. Let me take one more example. See, these are very simple concepts. Next problem I will take it as second problem. Test